ISO16363 is the Space Data and Information Transfer Systems Audit and Certification of Trustworthy Digital Repositories that is published by the International Organization for Standards. In 2009, development was started by the Mission Operations and Information Management Services (MOIMS) of the Consultative Committee for Space Data Systems on a standard for trustworthiness. The development was led by participants from NASA and NARA. The standard was based on the Open Archival Information System standard and the prior work done on track. The MOIMS Repository Audit and Certification Working Group recommended best practices for assessing the trustworthiness of digital repositories. In 2012, an international effort was started under the leadership of David Giaretta as an ISO standard. The MOIMS RAC work was used as a starting point for the standard. The MOIMS RAC standard is based on the OIS Open Archival Information System standard ISO 14721. MOIMS RAC defines three categories for evaluating trustworthiness, available at Life Zone Home RW Moore Class INLS 624 ISO MOIMS-RAC.doc. They are organizational infrastructure, digital object management, and infrastructure and security risk management. The MOIMS RAC document was the basis for the ISO 16363 standard. An analysis was made of the tasks specified by the MOIMS RAC standard, including a comparison with TRAC, available at Life Zone Home RW Moore Class INLS 624 ISO IRODS-V3.doc. For each task, a set of rules were identified. The rules were summarized and are available in Life Zone Home RW Moore Class INLS 624 ISO-IRODS.xls. A total of 165 rules were identified. Many rules for generating reports for the TRAC analysis were generalized through the addition of input parameters. The creation of rule sets for trustworthiness have evolved from ERA with 853 requirements, to RLG Narrow 174 rules, to TRAC 105 rules, to ISO 16363 165 rules. We appear to be reaching a good definition of a required set of about 170 rules needed to implement trustworthiness. Examples of the requirements are shown here. The requirements are very similar to those for MOIMS RAC and TRAC. Note that requirements can be met with policies and through capabilities provided by the data grid middleware. For instance, enforcement of access controls is done by the middleware, but a policy is needed to decide which access controls should be created. The examples listed here define requirements for the repository, for identifying content information, for providing procedures to identify information properties, for complying with access policies, for logging and reviewing all access management failures, etc. The 165 rules identified for ensuring trustworthiness can be analyzed for their general properties. The rules represent 6 fundamental types of operations applied to 7 types of objects. The fundamental operations are copy, create, execute, move, read, and update. The operations are applied to files, the database, events, metadata, policies, procedures, and ontologies. If we look at the rule summarization in Life Zone Home RW Moore Class INLS 624 ISO-IRODS.xslx, we find multiple types of events that need to be created, multiple types of reports that need to be created, and multiple types of metadata that need to be created. It may be possible to reduce the number of rules that are needed if they can be parameterized to handle the specific instances for each class of objects. Example tasks are shown here. Each task is categorized by the type of operation and type of object. The task is defined and given a rule number. Thus, the task to replicate a file requires a copy on a file. A task to record compliance with preservation policies requires creation of an event. A task to generate an AIP based on an AIP template requires the creation of a file. The tasks that are listed here operate on files, databases, events. They range from creating an authentic copy and verifying the checksum, to replicating a file, to synchronizing the replicas, to synchronizing files to a federated archive. Please take 7 minutes and complete exercise 100. Pick an ISO 16363 requirement and select a rule that would meet the requirement. See Chapter 7 of the Policy Examples Workbook on Data Management Plan Policies. Please load a paragraph describing your result into the Lifetime Library in the sub-collection class INLS 624 by the end of today's class. The National Science Foundation funded Syndicate project is creating a block-based content delivery system for use by academia. This is an example of the integration of data management services into the Internet. Internet 2 is evolving from a communication and data movement system into a network that provides integrated services. The approach is based upon software-defined networks that use policies to control processes within the network. There are multiple examples of services that could be provided within the network. Network caches. Data distribution can be optimized by creating distribution points that are close to the users. This turns wide area network data transport into local area network transport. Security. A policy-based virtual private network can be created for managing data flows. This ensures that data transport only goes between selected sites. Collection and file-based addressing. Since data grids support replicas, an IP address no longer designates the only location where a file is located. The replica closest to the user should be selected for access. Cloud storage. The naming of files and collections can be managed within the network, which enables data access by file name. Storage in the cloud can be integrated with local storage, with files distributed between the systems. The Syndicate project is modeled on the cloud services being offered by Amazon. Storage servers are installed at Internet 2 routing centers. Network traffic can be cached at the routing centers to accelerate delivery of academic data. The software controlling the caches is based on content distribution networks such as Akamai. Capabilities that can be implemented include hierarchical storage with caches in the network, workflow orchestration with workflows that are distributed across multiple servers, virtual private networks for secure transfer of patient data between researchers and repositories, file naming, distributed monitoring of processes. The capabilities are linked to the idea that DataGrid middleware manages distributed state information related to file naming. Since networks manage distributed state information for site naming, combining the two systems is feasible. A mapping is needed between the state information for sites and the state information for files. This mapping is provided by DataGrid technology. The integration of policy-based data management with policy-based networks can virtualize all the components of scientific research. For distributed analyses, researchers need to be able to virtualize data collections and manage the properties of the collection independently of location, virtualize workflows and manage the execution, provenance, sharing, and re-execution of a workflow, virtualize data flows, and manage the naming, sharing, and re-execution of the data flow. By managing the data, computations, and data movement, researchers will be able to reproduce their research results independently of the original research environment. The virtualization maps the workflow to cloud resources for computation, the data flow to a virtual network, the data collections to storage resources for archiving. The initial goal of the Syndicate project is to build a content distribution network service. The network-based caches are being integrated with the iRODS data grid for long-term data management. A block-based caching infrastructure will sit on top of the iRODS data grid, enabling distribution of blocks from a file. The data movement will be managed using software-defined network policies. The applications for the distribution network will include secure data delivery for academic projects and a proposed data delivery service for access to the digital preservation network.